All right, welcome to the Explainer. If you're deep in GCSE chemistry revision, you know those calculation questions can be, well, a bit of a headache. So today, we're going to laser focus on one of the most important skills you'll need for your exam, absolutely mastering concentration calculations. Let's get you ready to smash those questions.
Okay, let's just dive right in. Picture this. You're in the lab, and in front of you is a beaker full of a clear, colorless liquid. You know it's an acid, but how strong is it? Really, how concentrated is this solution? I mean, you can't tell just by looking at it, right? We need a proper way to measure its strength, and we need to be precise. And, this isn't just some textbook problem. For a chemist, knowing the exact concentration is pretty much everything. It tells you how a reaction's going to behave, how much product you're going to make. It's all about making sure your experiments are accurate and you can do them again and again. It's a fundamental question chemists ask every single day.
And for your GCSE, you get to be that chemical detective. You're going to get a scenario, a bunch of data, and your mission, should you choose to accept it, is to find the concentration of an unknown acid or an alkali. It's a classic problem-solving test, and don't worry, we're about to give you the perfect tool for the job.
So, what is this amazing tool? It's all about the concept of concentration, and we measure it in a very specific unit, moles per decimeter cubed. Now, I know that sounds a bit scary, but honestly, it's just a standard way of saying how much stuff is packed into a certain amount of liquid. That's it.
Let's just break that down a bit. A mole? It's just a specific quantity of a chemical, a bit like saying a dozen. And a decimeter cubed, or dm cubed, that's just a fancy name for a liter. Easy. So concentration in moles per dm cubed is literally telling us how many moles of a substance are dissolved in every single liter of that solution. It's the standard unit chemists use everywhere.
And here is. This beautiful little formula is the key to, well, everything we're doing today. Concentration equals moles divided by volume. The best part is, if you know any two of these things, you can always find the third. This equation is going to be your best friend for these questions, so you've absolutely got to know it by heart.
Okay, so that's the theory. But how do we actually find these values in a real lab situation? Well, we use a technique you've probably done in your required practicals. It's called a titration. So let's walk through a typical exam-style problem and see how we can put our magic formula into practice. So a super quick recap on what a titration is. It's a really precise method where you carefully react an acid with an alkali until they've perfectly neutralized each other. The trick is, you use a solution where you know the concentration exactly, we call that the standard solution, to figure out the concentration of the mystery one. You'll be using a pipette for measuring an exact volume and a burette to add the other solution drop by careful drop. Right, here's a typical set of results you might see in your exam. So, we've reacted sodium hydroxide, that's our alkali, with some hydrochloric acid. Now, look at the table. We know the exact volume and concentration of the sodium hydroxide we used. We also know exactly how much of the acid it took to neutralize it. Our mission is to find that big question mark, the concentration of the acid. Now, when you see a table like this, the first rule is don't panic. Seriously, there is a simple, repeatable, three-step method that will work every single time. If you just follow these steps, you are going to get to the right answer. So let's break it down. And here they are, your 3 steps to success. First, you calculate the moles of the stuff you already know everything about. Second, you look at the balanced equation to figure out the mole ratio. And third, you use that ratio to calculate the concentration of your mystery solution. Just remember, known, ratio, unknown. Simple as that.
Okay, step 1. We're going to calculate the moles of our known solution, the sodium hydroxide. We just rearrange our formula a little bit. Moles equals concentration times volume. But wait, there's a massive trap here. The volume in the table is in cubic centimeters, but our formula needs decimeters cubed. This is where so many people lose marks, so always check your units. We just divide 25.0 by 1,000, which gives us 0.025 dm cubed. So our calculation is 0.100 times 0.025, which gives us 0.0025 moles of NaOH. Step 1, done.
Right. Step 2 is all about the mole ratio. You get this from the balanced symbol equation for the reaction. In this case, it's super simple. 1 HCl reacts with 1 NaOH. That means the ratio is 1 to 1. For every 1 mole of sodium hydroxide, we need exactly 1 mole of hydrochloric acid to neutralize it. So if we used 0.0025 moles of NaOH, well, then we must have had exactly 0.0025 moles of HCl in our flask. See? Easy. And finally, step 3, we're on the home stretch. We just bring it all back home with our magic formula again. We want the concentration of our unknown, the HCl. So, concentration equals moles divided by volume. We know the moles, it's 0.0025. And we know the volume from the table, it was 20.0 centimeters cubed. But remember the trap. We have to convert that volume into dm cubed first. So we divide by 1,000 to get 0.020 dm cubed. Now we just pop the numbers into the formula.
So, 0.0025 moles divided by 0.020 dm cubed equals 0.125 moles per dm cubed. And there it is. We've done it. We've taken our data, used our formula, followed our 3-step method, and found the unknown concentration. The mystery is officially solved.
Fantastic. Now, before we finish up, let's just quickly recap the things you absolutely, positively have to remember for your exam. Think of this as your final checklist before you walk in there and get all the marks. First things first, and I'm going to say it one more time. Always convert your volumes from centimeters cubed to decimeters cubed by dividing by 1,000. It's the easiest mistake to make, so just make it the first thing you check. Then, burn these 3 steps into your brain. 1. Find the moles of the known. 2. Use the mole ratio from the balanced equation. 3. Calculate the concentration of the unknown. Known, ratio, unknown. If you can drill that, you'll be absolutely fine. So now that you're a pro at concentrations, here's a little challenge question to take it to the next level. If you know the concentration of our acid is 0.125 moles per decimeter cubed, how would you figure out the actual mass, in grams, of HCl in a 250 centimeter cube sample of it? This question connects everything we've just done with relative formula mass. Give it a go. Thanks so much for joining me on The Explainer.